So not storing pesticides properly. Yes, so we're supposed to store pesticides in a well-ventilated area, right? Because sometimes they will vaporize, right, depending on their vapor pressure. Yes, so just like the concentrated pesticide in a storage facility or an inappropriate storage, right? Anybody else have anything else to say about air?
In line with the overspraying or spraying when it's windy, aerial application, especially where I live. I mean, there are times when either helicopters or planes are spraying, and I'll fly, if you're driving along that road, and all of a sudden you realize, oh, I gotta be getting exposed if I can smell it that strong, you know?
So what makes aerial applications different than, say, a ground application? Just a regular old ground boom?
Probably the density of the difference.
So why are aerial applications, aerially applied pesticides more likely to drift?
Because of the particle size and
They typically have larger droplets,
okay.
which do drift less, but they have larger droplets for a reason, right? Because they're releasing the spray way up here. And as the droplets fall, they can be evaporating. And as droplets evaporate, yes, pesticide enters the air, but also it's so much easier to drift if the droplets are smaller. It's easier to move off site. But the main thing with aerial applications is they're going faster, right, than regular equipment, but also they're releasing it from way up high. And so it just gives the air so much more chance, right, to move it off site than if you're on a ground boom and you've got it like 12 inches above the plant medium. I'm not saying drift doesn't happen here, but it is easier to happen with an aerial application or like an air blast application where things are high pressure, purposely small droplets, and going kind of outwards instead of down, okay? And I think I've got lots of things to talk about that as well. So before I move on, this is not the last that we're gonna talk about this. I mean, we're gonna talk about pesticides in water more and drift more, but is there anything that you guys wanna add or ask before I move on?
I want to add improper notification or signage, and that could be for both occupational and air.
Yeah,
Sorry.
so when a pesticide has been sprayed, right? This is the situation you're talking about? And nobody has posted that there's been an application. Sometimes we have to post and sometimes we don't, but let's say we were supposed to post and we didn't. And then so what situation can we run into with that?
Somebody could enter the applied area without knowing that that pesticide is there.
Yeah, and so the level of residues in the field right after application are the highest that they're going to be. And so there's a certain amount of time that we are supposed to wait between when the application ends and when any regular old person is supposed to enter that field. So obviously the applicator who's trained and equipped with PPE can be in the field during that application, but really nobody else. And then there's a certain amount of time, it's called the restricted entry interval, or REI, that we call it for short. That's what's it called? Initials? Or
Acronym?
yes, the acronym, thank you. So anyways, there's a certain amount of time, and that amount of time depends on the pesticide and sometimes it depends on the rate and what you're spraying, where nobody's allowed to go in. And that is typically when we post the do not enter pesticides danger sign, right? And if we haven't posted that sign and somebody goes in, they might be exposed to, they're exposed to higher levels of residues than they should be without extra protection. So that it could be a respiratory hazard, it could be a dermal absorption hazard, any number of things. That's exactly correct. So anybody want to add anything else? Okay. So I like to sort of start with this because a lot of times humans, there's a lot of ways that we have direct exposure to humans, right, of pesticides. Food, and then obviously occupational, living or working in or near agriculture or where pesticides are applied, right? But we're also exposed to pesticides through our environment, right? So just any old person who doesn't, work in agriculture, you don't live near agriculture, you still could be exposed. And so that's why it's ever more important to use pesticides appropriately. So this is what I came up with. So I think spray occupational exposure and even excess food exposure, because if you've got the drift and it moves to where it shouldn't be, and that is like a strawberry field or what have you, something that we eat. And then obviously pesticides get into the water like that. And then leaching and runoff, that primarily impacts, water, obviously. Those are water processes. And then particle drift, and that's primarily like when we've got soil with pesticides attached. Sometimes instead of moving with the water, there's soil erosion, right? There's excess wind, we don't have any ground cover, and those soil particles can move with the wind, right? And so that can deposit pesticides via particles to people who work in the field, into the air, into the water, what have you. And then VOCs, volatile organic compounds. Some pesticides volatilize much more readily than others, and that is primarily an air contaminant, but obviously occupational exposure is in there. Okay, so I've got a couple of slides for this because I don't have one that I really love. So this is how pesticides get into the environment, right? So I have a laser pointer. So we talked about this, right? We've got, we talked about some of these. So this is the soil surface, so we apply pesticides here, and sometimes they go down here and they leach into groundwater, or they percolate little by little. But leaching is a negative term. It's typically negative. It means something happened that should, like excessive pesticide, excessive water, or something in the management didn't happen correctly. And then, again, with the soil applied pesticides, they can move, when we move soil particles off-site with the water, they will deposit into surface water. But again, surface water and groundwater will eventually mix. It'll take a long time, but it does mix. So it's important to protect both of those water sources. And then sometimes we have evaporation or volatilization. So this can happen either from the leaves when we apply pesticides onto the leaves, or even when we apply it onto the soil surface. And then pesticides are supposed to degrade, right? They are supposed to degrade little by little by little. We expect this to happen. We don't want pesticides in the environment forever. But there's just many different ways that pesticides degrade, and some are like, here in the root zone, it's so microbial action in the soil, then again volatilization, and then photodegradation can happen. I don't have a lot of information on like how common photodegradation is. If something is not photostable, we are probably not using much of it in outdoor applications. But I do believe that pesticides, like if they're past their prime, they are going to be less efficacious, in part because they will degrade more quickly. So I think, anyways, I don't want to talk that much about photodegradation. So there's just many different ways that pesticides will get into the environment, and sometimes it's like just little by little by little, and an expected process and built into all these risk assessments, and sometimes it's not. Like with leaching and runoff, we really don't want pesticides to get into our water unless we purposely put pesticides in the water. Like, so sometimes we apply pesticides through an irrigation system, so like a drip, through the drip tape, or like even through overhead sprinklers. We purposely put pesticides in that water, but we have to be really careful to put backflow so that the water source doesn't, like the actual source of the water, the natural source of the water, then isn't contaminated by pesticides. But it's very, very common to inject pesticides into the irrigation water. So obviously that's where we want pesticides there. And then sometimes we make pesticide applications directly to water, like for mosquito control purposes, we're doing it right on irrigation canals or directly into the water. Some pesticides you actually can apply directly to water, okay? So, but barring those sort of two situations, we really don't want pesticides in our water, right? So this is another slide that's trying to say something similar to the previous slide. It says a little bit more, but it's really busy. I don't love it. So we've got drift, dusting drift. So that says to me particle drift. That looks like soil particles being kicked up by this tractor, but sometimes even if we make an application of dust, that can also drift. So we've got aquatic applications, that's what I was talking about. So we are purposely applying pesticides to that water. Like a broken pipe, like all different ways that pesticides will end up in the water. Okay, so, let me see. Okay, so in general, the environmental contamination of pesticides is dependent on some of these factors, all of these factors, but the nature of the contamination is dependent on a subset of the factors. So pesticides, their chemical composition, whether they're soluble or whether they're really adsorptive, right? So adsorptive means that they bind very tightly to the soil. Soluble means that they dissolve in the water and they can move that way, okay? So those pesticides, because of their very chemical composition, are much more likely to end up in the water. And then persistence is really important in a pesticide. We want it to be somewhat persistent because we don't want to have to keep reapplying that pesticide over and over and over again. But if we've got something that's excessively persistent, what is the problem with that?
Never breaks down.
Yeah, it doesn't break down, so it's always there with the potential to move off site, right? So this is what we find. I'm sort of giving away my answer. So if you've got a pesticide that's very absorptive, so it likes to cling to the soil particles, and it's persistent, it's going to stay on that soil particle for a long time. So much more chance that there's going to be excess water to move it off site, right? So a less persistent pesticide is less prone to runoff. Same thing with leaching, right? So if it's in the soil water for so long, much more chance that we're going to make a mistake with the water management and move it down into the groundwater potentially. Sometimes our formulation has an impact on how a pesticide moves off site. And a lot of times that's with our VOC production. So what do I mean by formulation? I'm talking about a pesticide formulation.
How light or heavy the concentration is?
Okay, concentration has something to do with it. So when you say light or heavy, what do you mean?
Say you were gonna apply it to your vineyard and you used more of the pesticide than you should compared to how much water you're mixing into it.
So you've made it too concentrated, right?
Yeah, you've used.
Okay. So when I say formulation, so that is a factor in moving in pesticides in the environment. So here I have a pesticide jug. I didn't go to art school. Okay. So when I talk about formulation, I mean and not necessarily even the jug. It could be a bag, right?
Okay.
It's
what form
what
it
it
takes?
comes in,
What
right?
form
Like
it is.
before you dilute it, this is formulated in a certain way. There's a formulation in here. So if it's a jug, it's a liquid formulation, right? Because it's a liquid. And there are a bunch of different liquid formulations, like could be a soluble liquid, could be a emulsifiable concentrate. It's sort of like what it is. So if it's a super soluble or emulsifiable concentrate, it's like, does anybody know what an emulsifiable concentrate is?
Salad oil.
It is like salad oil. So what is salad oil? You've got like an oil and a vinegar, and they don't like to mix. They taste really good together, but they don't like to mix. But you put an emulsifier in there, and they don't fall out of solution. So an emulsifiable concentrate, the abbreviation is EC. It's something that if there's a lot of oil in that mixture, and so that's going to be important for our future discussion. So, but it's basically a mixture of two things that normally wouldn't mix, but we've emulsified them. So the formulation is there's the pesticide active ingredient, which does the actual killing of the pest, right? And then you've got all these carrier ingredients or adjuvants or other things all mixed in together that make the pesticide actually do the job it's supposed to do.
Make it applicable.
Yeah, so usually the active ingredient all by itself, it doesn't do anything. It's got to be sort of mixed, like it's like it takes a village, right? Mm-hmm. So it like takes a combination of things. And so an emulsifiable concentrate is very oil heavy. And so these are the ones that that are much more likely to absorb into our skin, because our skin likes to absorb oils, right? That's why you put lotion on it. And then they also are much more likely to volatilize, okay? Or they're much more volatile. So What I'm saying is like the active ingredient itself is the pesticide, it's the chemical molecule that is killing that insect or that disease or whatever. It can be formulated in multiple ways. So the vapor pressure or the volatility of the active ingredient is very important, okay? But if it's formulated, if we have an active ingredient that has a so-so volatility, right? It kind of volatilizes, but then we formulate it as an EC, it's gonna increase its volatility. Whereas if we formulate it as water dispersible granules or something else, that's not as volatile. So this like makes the active ingredient much more prone to volatilization, okay? So the formulation is, it's just sort of how the pesticide comes in the original container. So it could be formulated as a dust, a granule, a water dispersible granule, which is like, it's almost like an EC, but it's a granule that sort of suspends in the water to do the job as opposed to solubilizing. And there's just different, liquids, and so like emulsifiable concentrate is a real heavy liquid, whereas we have some that are more soluble and they're less heavy. So I don't want to talk too much more about formulation, but you should know about emulsifiable concentrates because it'll come into play later. But yeah, just how it's formulated will determine its ability to move off site, either volatilization or like sulfur typically comes in a powder, but sometimes it's a dusting powder and sometimes it's a wettable powder. So the wettable powder we mix with water and we spray it as a liquid, okay? And so that has a potential to move off site, but the actual application as a dust, it also has the potential, like it has more of an inhalation hazard, like sort of moving off site because powders are sort of lightweight and it can, you have to be really careful with dusts applied, as a solid. So application rate, that's kind of what you were getting at, I think. Like how much pesticide is in that water that you're spraying? How much pesticide it is in that tank that you're spraying out? So more pesticide, the higher concentration, more likely that pesticide is gonna end up in the environment. And I'm not saying you should, if the label says one concentration, you should go below that, right? So we've got to follow the label for efficacy reasons, but we have to make sure that we're applying at the right rate and not an excessive rate. Frequency of application, that is just like the more pesticide you put into the environment, the more likely it is to move off-site and to contaminate the environment. Environmental conditions, so what are some environmental conditions that might impact how pesticides move off-site?
If it rains.
If it rains, right? We just talk, my lovely drawing is illustrative of like, if it rains, we might have some problems, right? If it's excessive rain. Can we control the rain though?
I can.
No, we can't.
I can't.
But we can predict the rain to a certain extent, right? Okay. There are weather forecasts, right? So what are some other environmental conditions that might impact the way pesticides get into the environment?
Soil type.
The wind, and I've got soil type. So the wind, we'll talk about that later, but it's also kind of obvious, right? So wind moves the pesticide.
Yeah, I control that too.
Yeah. Again, we have to look at the weather forecast, right? And continuously monitor the wind. But tell me what you mean by soil type. Tell me more about that.
Clay versus say sandy, I think.
Okay, so what is it? Like if I had a sandy soil, how might that increase my environmental contamination?
Leaching would be higher.
Yes, so I told you it was because of the pesticide, and I'm not wrong, but neither are you. So it's the soil type and the pesticide type, and then our management practices, right? So if I have sand, okay, not drawn to scale, okay. So if I've got sand, I have larger particles, meaning that the spaces in between my particles are also larger. So soil water moves there much more rapidly or much more readily. And then, so tell me what's going on with our clays. Obviously, I have smaller soil particles.
It's less permeable.
That's right. So it's less permeable for a variety of reasons, right? First of all, the spaces in between the clay particles are smaller. So it's like if you got a really big straw, you can suck up more Coca-Cola than if you've got a really skinny straw, right? So like when you get an alcoholic drink, they put the really skinny straws. right? Because they don't want you to drink it that fast or something.
Sometimes they'll give you 2 of them though.
That's true. Still not as efficient as one larger one of an equipment, right? You know, so it's hard, you need to get anything out of them. So water doesn't move quite as quickly, but also like there's all these negative charges on the outside of clay particles. I'm not a soil scientist, but I'm married to one, so I know this. No,
Nice.
we don't talk about soil. No. So there's negative charges, and so a negative charge is much more likely to be adsorptive. And adsorptive means binding power, right? So the pesticide could have binding power and the soil could have binding power. So much more likely that an adsorptive pesticide is going to stick on the surface rather than get into the water, the soil water. Okay, so I love these answers. You guys are really smart. Okay, so application type. We sort of talked about that a little bit, didn't we? So with the aerial application, right? Aerial application, much more prone to drift. And then air blast applications, and I'll talk about that in a minute, that kind of go, or air carrier, right? So they blast out. And then application practices. So you could have like a ground boom. Let's assume that a ground spray, so it's the release height is like here, let's just say that, and it's got typically larger droplets, so less room to fall, larger droplets. So if we call that the poster child of low drift, but then I increase my pressure or I increase my speed, I'm no longer the poster child of no drift, right? Because I haven't used good application practices. Or even like, so applying in unfavorable environmental conditions. Like that's kind of on the applicator as well, right? So we have to have good environmental conditions, we have to have the right pesticide selection, we gotta know our soil type so we can choose the right pesticide, but then we gotta put into practice, you know, these safe practices, basically, right? Okay. So,
Straight out of the book right here.
That's right. I scanned a copy of the book and I put it in there. But I just want to talk about this more in terms of sort of like drift. So there are different ways that we can apply pesticides, right, in a vineyard. So this is, I would say, this is probably the much more conventional, right? So this is what we would typically call an air blast spray. It's used a lot in orchards as well. So there are all these nozzles on both sides, and they push out at high pressure really small droplets. But I just told you that small droplets are prone to drift. Why in the world are we using small droplets? What is the point of those?
Because they get better coverage on the crop.
Right, because the bigger droplets, they don't travel as far, right? So that's the benefit, and the disadvantage of having small droplets is that they travel farther, so they can get deeper into that canopy, right? The bigger droplets aren't really gonna do that for you. So you do have to have, it's like this balance between a small enough droplet so you get good coverage, so you have good efficacy, right? Because if you don't have good coverage, you've just sprayed this pesticide and wasted money and exposed people, pesticide handlers for no reason. So you have to have good coverage, but not such small droplets that it's very prone to moving off site. But at least with the grapevine, if you're doing a good job and you've turned off the nozzles on the top, right, and you're actually appropriately, aiming that spray, and you can use different nozzles in here that are even with this application equipment that's so prone to drifting, and you can use lower drifting nozzles, like an air induction type, that you can get better coverage with minimizing the risk of drift. But this is what I want to say. So we've got purposefully small droplets, purposefully high pressure. That's a drifting situation. We have to be very careful to monitor the wind in those situations, right? The wind direction and the wind speed, right? So if the wind speed is more or less appropriate, but the wind direction is such that it's gonna move, if anything moves, it'll move right onto, I don't know, a river or a lake or something like that, then we have to be aware of that as well, okay? So you may not have a lot of control over the application equipment that you use. Because you're working in a vineyard, or what if you're working in an orchard? I mean, you don't have that many choices. And maybe also application equipment is really expensive, so it doesn't really there's not a ton of turnover, right? So you may be sort of stuck with this air blast situation. But we can overcome that, right? So there's lots of things that we can do, just monitoring sort of weather conditions, and also using appropriate nozzles, and also calibrating, and I'm not gonna get into that, but making sure you're putting out the amount that you think that you are. So you have to sort of like collect the droplets and measure them and time it, and so that is like an hour or two's worth of teaching, and I'm not gonna do it right now. But anyway, so making sure you have appropriate calibration, you change your nozzles every once in a while so they're putting out what they're supposed to, and that you're monitoring weather conditions. So these are all sort of like ways to do the same thing, but do a more directed spray. Well, this isn't so directed, right? This seems like a little bit, it's like this tower sprayer. But this is like these are all fans with nozzles on them. So these are kind of like new, very innovative. And like there's a lot more innovation, I would say, in things like strawberries and grapes because it's a high value crop, right? And so that's pretty cool. I even got to witness, I should have put it on here, but I have a little video of, oh my God, what do you call them? It's a helicopter, but it's like a miniature helicopter.
Drone.
It's not exactly a drone, but what is the technical term for a drone? It's unmanned aircraft or something like that. So the guy has to be a pilot who does the remote controls, and he needs a spotter, just like with an aerial application. But it's like this helicopter that's like this big, and it can get like this high off of the vines, and they can make those aerial applications like so close. So I mean, they're not doing that in things like alfalfa, right? Because UAV, yeah, yes, that's what I'm trying to say. Anyway, so lots of innovation, lots of really cool stuff happening. And then of course, so we've got these, this is also in a video, but like this is what I would say is a ground boom. This is a traditional ground boom, right? So we're spraying from here all the way to here. We're not actually spraying the vines, we're trying to get at weeds, right? This is what we're spraying here. We're spraying plants that aren't supposed to be there. And this one is particularly targeting sort of like at the base of the vines. So you gotta make sure your grapevine isn't susceptible to that herbicide, right? So that would be terrible. But so we're either spraying like in the middles or like the centers. The middles or the centers. I don't know the exact terminology, but like
the vine row or the middle.
Yes, the vine row or the middle. Okay. Okay. And so these drift a lot less because they don't have to be such high pressure or such small droplets in order to reach their target. And then also we have this advantage of we're purposely trying to spray these weeds when they are smaller. So they're easier to manage than like this really thick vine that you're trying to prevent powdery mildew on or manage powdery mildew on. Okay, so I want to make sure I check the time. It's 5.
It's a big clock.
Oh, I'm very observant. So I think I have a couple of slides I can talk about pesticides in air, and then we can break and then talk pesticides in water, which apparently is what I like to talk about the most. Okay, so pesticides in air. So as I mentioned in the other graphic, it can happen. I put all this animation in, and then I don't really remember how far the animation goes. So pesticides can get into the air through spray drift, which is liquid drifting off, moving off site. Particle drift, which is soil particles that have pesticides, bound to them that move in a soil erosion situation, and then pesticide volatilization. So some pesticides are prone to volatilizing, okay? And then if we're applying in certain environmental conditions, that increases the likelihood that it'll volatilize, okay? So this is the list of things that I told you, like environmental contamination with pesticides is dependent on these factors, but not every factor impacts every type of contamination. So I kind of already told you this. So the nature of the pesticide, right? If you've got a pesticide that really is not very volatile, it has not, you know, not the appropriate vapor pressure for volatilization, well, then it's probably not gonna volatilize, right? But then also we have to have certain environmental conditions and then also applicator practices. Like if it's really hot or if it's humid, right, then we're not gonna apply volatile pesticides, okay? So then it's kind of like the disease triangle in a way, right? You've gotta have the pathogen, you've gotta have the right environmental conditions, and you've gotta have the right host. It's just, we don't necessarily need the host, like the host is anything, right? So we've gotta have the right pesticide and we have to have the right environmental conditions for it to then volatilize. Okay. So this is more related to drift. I wonder if I should get into this. So we have talked about this in a general sense, right? Larger droplets move off site less or less frequently or less rapidly. So, what do I have here? Here I have sort of like a description of the spray from a very small, like a fog down to a fine mist, all the way to like a coarse spray, right? And so it's from smallest droplet size to largest. And so it's measured in microns. So we measure, a lot of times we measure droplets in microns. And then, okay, this is the time required for droplets to fall 10 feet, right? So sometimes.
Oh my gosh. 66 minutes? Fog.
Oh, I think I know why. Okay. A human hair is 100 microns, so that's why this is here. So
Okay.
anything smaller than this is smaller than a human hair. And so why is it that it takes 66 minutes for this really small droplet to fall? It takes a long time, right? But it moves so far. It moves so far because it's kind of suspended in the air, right? And so it's suspended in the air, and so the wind, it's much more prone to being moved by the wind. And this is all the same wind speed, okay? And so if you've got, as you go larger, it takes less and less time for it to fall. And that is a good thing, right? Because we want it to fall to the ground. We don't want it to move laterally, right? So, it'll travel 4.7 feet in optimal conditions rather than 3 miles, right? So we know that when we make a pesticide application, we have this liquid spray, we know something is gonna drift, but we want it to drift just like teeny tiny bit. Like even 5 feet, I would say is too much, right? So basically these fall much faster because they're heavier. So bigger droplets are heavier, and so gravity helps us out, and then they fall faster. But also, as I was mentioning before, if we have a really huge droplet, as it falls, it's going to evaporate, okay? But if you start off like this, and then it evaporates, right? Versus if you start off like this and it evaporates. So the droplet is gonna be smaller when it hits the ground, regardless of its size. But the smaller it is, the more rapidly it evaporates, because it just like, it eventually evaporates into nothing, and then it's only in the air and it doesn't even fall. So it's just, larger droplets fall faster, right? And they don't move laterally quite as easily, okay? But of course, we've already discussed that there's this balance between you can't just go with the coarsest droplet size you can possibly get, because you might not get really good coverage. So if you've got a pesticide that requires good coverage, right? So it's I've lost my words, it's Friday night. So if it's like something that needs to cover the entire surface of the leaf, so if it's not a contact pesticide, but a systemic pesticide, that's what I'm trying to say. You know, like there's a difference in coverage that's required, right? So, anyway, so if you want good coverage, you can't just choose the coarsest droplets. But there has to be a balance, because if we choose really small droplets for good coverage and then our pesticide moves off site, that is no help to anybody. Yes.
So if you go with like a very coarse droplet, like fine rain, is that gonna increase like also like the runoff of the
It
application?
could, I mean, there's actually with something that big, there is splashing that happens, so like a bigger droplet hitting the soil surface is gonna splash, so if you've got a plant here, you could get some phytotoxicity because of the splashing, because the droplets, or like the droplet is, first of all, it falls and it's too heavy to sort of sit on the leaf.
Right,
So it
right.
falls to the ground and it splashes up. So if you get
Or it
too
almost
big,
seems like
this is this is kind of sloppy, right?
Right.
This is like a sloppy rain. So a coarse or medium droplet, 240 microns is kind of like, I don't want to say it's a happy medium, but it's a really good size. It's not super sloppy like this, and it is not too small and driftable, right? So 240 is a good droplet size
Okay.
for a lot of things, but you're not going to get 240 microns in an air blast sprayer. So
Well,
like if you've got a ground boom, 240 is great. If you've got a
Right.
backpack sprayer, 240 is great.
And so based off the right side over here, I mean 40, even for the fine spray of 44 feet,
Mm-hmm.
I mean,
But-
if you're not within, you know.
Remember, it's falling 10 feet. 10 feet is really high as
Right,
well.
right,
I
that's
should have
true.
pointed that out first. So,
Right.
like, yes, this is
So you
this
can
is
you can do some,
excessive.
so I mean if you're spraying from 5 feet or most likely 3 or less, you can divide that, right?
It's not really divisible. It's not like a 1-to-1 curve. It's extrapolatable, but it's not like 1-to-1. It's
Okay.
not like if you 5 feet, it's not 1.5 miles exactly. I think you would have to do it. I think you would have to do the experiment all over
Right.
again with a different release height.
Okay.
Okay, and if you change the wind speed, same thing. Okay, but yes, you can assume you know, you don't even have to assume. You know that if this is 5 feet, this is absolutely going to be less than 3 miles.
Right.
This is absolutely going to be less than 66 minutes. I can't tell you exactly what that is because
Right.
it's not like a exactly 1-for-1 ratio.
It all depends on your application too, doesn't it?
Well, so the droplet size is really dependent on like your nozzle and then the pressure in the machine.
I mean, if you're
And
coming
then,
down.
you know, we've got a 3-mile-per-hour ambient wind, but then your application equipment can be going really fast, like with an aerial application,
Oh,
and so that sort of creates its own air currents as well. And then the air blast sprayer is designed to make its own air currents. And then this sprayer, there's fans for Christ's sake. I mean,
Right.
there are fans, so like there's air currents created also by the application equipment. So yes, this is an experiment done in a vacuum to sort of have an impact on smaller droplets are going to move off site. So yes, this is probably conducted in a spray chamber in very controlled conditions. So on the ground, in the field conditions, it's not going to be exactly this, but it's going to be something that looks like something like that. Yes?
Does temperature, the outside temperature, have an impact on volatile? I guess it's your next slide.
So does temperature have an, yes, obviously temperature absolutely has an impact. Tell me what you think that impact might be.
Just a faster evaporative rate.
Yes, droplets are going to evaporate much more quickly at higher temperature, right? And so, yes,
Spray at night.
spray at night, yes, people do that, but you know, there's hazards associated with spraying at night as well. Like you can't see very well. It is like OSHA has this campaign on like making night work in general safer, but also spraying pesticides at night safer.
I haven't been around any commercial spraying, but how much guidance does an applicator receive in terms of, like the manufacturer of pesticide suggested you're going to be using a medium spray, and is a medium spray here the same as the medium spray that he's using over there?
So different pesticides, and then the formulation is going to change things. But So I'm gonna go back to your question, your initial question, right? How much guidance does the applicator get? So, like if you're a commercial applicator, you get this guidance on a lot of things, but in terms of like directions directly from the pesticide manufacturer, oftentimes if the pesticide is particularly susceptible to volatilization or to drift or something like that, or like if you have something that you're putting in an air carrier sprayer, so you know it's driftable, then yes, oftentimes you've got do not apply this in more than a 5-mile-per-hour wind or something like that. There are some pesticide labels where they give you those very specific instructions, absolutely. And then, so we also tell applicators there is a wind speed range that is the most appropriate. But I'm not gonna tell you what it is because we have to take a break, so I want you to think about it over your break, and I want you to come back and tell me what the wind speed range is, and then we can talk about that. So, should we take, how long of a break do you take?
I'm not like 5 minutes
Oh, okay.
to get through.
All right.
But
Hey, at least
it's
you give
okay.
breaks.
Well, that would be brutal, but yeah, let's do that.